Hi, I'm Andrew, and I was an undergraduate researcher at the Department of Environmental Engineering this summer. The basis of my project, which was done in Dr. Spiros Pavlostathis' lab, was revolved around designing a microbial fuel cell. Microbial fuel cells are very simple in concept. You have an anodic and cathodic chamber, and inside the anodic chamber, bacterial colonies are used to oxidize incoming organic substrates, which releases carbon dioxide into the environment, electrons which travel through an external wire through a resistor into the cathode, and then the protons travel through a proton exchange membrane. While in the cathode, the protons, the electrons, and oxygen from the environment combine to form H2O, and this gives you your current. Unfortunately, the reduction of oxygen to water is quite a slow reaction, requiring the use of a catalyst. Platinum is the most commonly used catalyst, but it is quite expensive. My research focused on utilizing a biological catalyst as an alternative, an enzyme called lactase. Lactase is a highly useful enzyme in industry, particularly for green energy applications. It contains a 4-copper center that catalyzes the reduction of oxygen to water. Furthermore, we bound lactase to single-walled carbon nanotubes. The carbon nanotubes stabilize lactase, allowing it to operate in suboptimal pH and temperatures. It also serves to anchor lactase, providing a consistent site of reaction. We tested lactase single-wall nanotube conjugates by reacting it with the substrate. Our two control groups showed little to no activity while our experimental conjugate did, indicating that lactase could bind to and retain activity while bound to nanotubes. Finally, we tested the conjugate as a cathode catalyst in a real-time working system. We were using our two-chamber configuration, and we needed to compare our experimental group to a submerged platinum cathode serving as a control. Each group was fed 400 microliters of acetate and was kept on a 7-day schedule. Our experimental cathode showed a more stable current output as well as an interesting ability to maintain current during a cathodic overpotential, which severely inhibited current generation in our control group. Additionally, our lactase carbon nanotube consumed less substrate to produce a greater current, indicating higher efficiency in converting substrate to current. Further experimentation will be needed to be done to support both observations. I would like to thank the Pavlostathis Research Group for its support.